We are currently going back to page 780, and we are going to be looking at number 80. Now, basically, I'm just going to give a little synopsis here at the top of the page of what we're being asked for.
What's that word mean?
A little review. We are in school, at least on here, from 8 a.m. to 3 p.m. So it asks us to draw a diagram that shows the number of rotations completed by the minute hand of the clock.
Dang, that's like 700 million. From
So rotations of the minute hand during this time. Find the measure of the angle generated by the minute hand. Give the answer in degrees and radians. Okay, now let's make a comparison.
8 to 10.
Here's the example we had in the notes. Find the degree and radian measures, okay, same thing there, through which the, hour hand rotates. Now here's the difference. When we were talking about the hour hand, we can go through an entire hour and it only moves that little bit. So we had to divide by 12, which got us 30 degrees per hour it was moving. But now let's try to apply that, let me move this down a bit, to what we're doing here. So before I ever start drawing this picture, let's think about this for a second. If I have a clock, and now I'm looking at the minute hand every single hour, how much of a rotation is the minute hand doing over an hour's period? 360, okay?
60 every minute.
So 360 degrees per hour when I'm doing the minute, okay? So that's a little bit different.
And then you gotta find how many hours.
Yeah, and I still have to figure out how many hours this is going to be. Now that was a challenge yesterday. Hopefully today it's a little bit easier. 8 a.m. to 3 p.m. is 7 hours. So here's a couple of things that I know. First, when I do degrees, if it's 360 degrees per hour, and this has been occurring for 7 hours, my central angle would be 2,520 degrees. Mercy.
Dang. Man, you should have done the other one. No, too easy.
Again, but that's why I say, keep this stuff out and handy. Just because the first time you go to do it, you can't do it off the top of your head doesn't mean you're not capable. It just means you got to look at something a little bit. Now, I'm not done, because there's a couple of things the question still asked me to do. First, it asked me to put them in both degrees and radians. So now I can get this out of the way. How do I turn this 2,520 degrees into radians? It was just up there.
Times 180.
I will talk about that right now.
What are we doing now?
Now, I had a brilliant opinion just mentioned to me. Is this a positive or negative degree that we're looking at?
Well, it's a negative.
Why is it a negative?
Because it's going to be going clockwise.
Right. It's those types of details that we've got to be watching for right now. Because if I go clockwise, which, well, duh, when you're doing a clock, that's what you do. Okay, that's a negative. So, if I multiply this out, oops, almost lost my pi. Now, what's that? I'm- So, can I reduce the fractional portion of this? So we got our heads. Head is nodding yes to what? Negative 14. Okay. Degree and radian measure. And the one other thing it's asked is, it says draw a diagram that shows. Now I don't mean like my clock here. When we talk about doing this, what I'm going to do is I'm going to literally draw like I would with the angle. So you're going to draw negative 2,520 degrees. Yes.
All right.
You're going to think that you're looking in one of those like funky things from back in the 70s when I get done. So here we go.
Glasses?
Oh yeah. So now I am not going to write every degree measure along the outside of here. That would take forever. So I've just got to keep counting by 360s here. And if I need help, here, I'll give myself help if I need it.
Your crutch.
My crutch is ready and available.
I had to dig for this one, man.
Okay, hang on.
Oh, he's like, yeah, this is mine.
Okay, so if I start going with my clockwise rotation, so here we go. One full is 360.
Bang.
Another full, now I'm up to 720.
999.
No.
Wait,
Oh boy.
who's that?
All right. Whoa.
Seriously, can you
Another
imagine?
full rotation. I'm up to 1080. They're like, oh crap. And why does my pen keep dying? 1440. And another 360. I'm just going to start doing this in my head now because I think you get the idea. Gets me to 1800. 2160. I only got to do this one more time. And perfectly
500.
ends up at negative 2520. Basically, I have 7 full rotations is what I'm looking at here.
That's too many.
But that's how we signify degree measure angles. Because, I mean, you can't really look at a single circle and say a 2500 degree angle. It just doesn't work. So that's how I kind of work this out. At least I didn't have to draw an angle in on top of it. That would have been kind of not fun. But you noticed in this one being done, yeah, the only real thing I had to mess with here is now instead of being the hour hand, it was the minute hand, but it's still not something, it's something that you're capable of doing. Because 82 is going to be exactly like example 23. I mean, it's even a sprinkler again. So use the example to help you if you're not getting the right answer. If there's something we got to tweak later, we can, but you've got to try something first. That's why we have difficulties with story problems, because half the time we don't attempt them. Other issues back on 780.
The radius just be how far it sprays.
Absolutely. Because if you think about that, here's the one thing I will say about 82. Because on 82, it says the sprinkler rotates 140 degrees and sprays up to 35 meters. So you're like, now how do I know that that's the radius? Well, here's how I know. If I thought about this for a minute, I'm just going to quick sketch this. I'm not going to measure it out. Okay, so if this was my 140 degree angle, when you think about a sprinkler, okay, it's not saying it's going in a 360 degree circle. If it was, then I'd have to think about this a little more. But what it's saying is, it starts here and goes, and keeps coming back and forth. Well, the whole time that's occurring, it's never going wider on either side than this, which would be the 35. That's how I know it's my radius. It's going from the center out to the edge. So they're not going to literally say it's radius, but that's what they mean. The only thing you have to watch for here is, remember, since you're looking for area, this needs to turn into radians. Pi needs to be in there instead of 140 degrees. So some of you tried it and you're like, I am not getting the answer you did. Probably because you haven't changed that degree measure into radians yet by multiplying by pi over 180. Bet you when you do, you will. All right, so if I go backwards a little bit here now, are there any non-story problem issues that we are having? Okay, so here's kind of my order, my to-do order right now. Let me get this out of the way. We're going to take a moment to discuss an epiphany that occurred during 4th hour yesterday, when we were talking on this side of the notes about finding our 6 trig functions, and we talked about how you can draw a picture, you can know the formula, but sometimes knowing the formula can get to be a bit tricky. Here's what we ended up coming up with. Started to look at this. People are like, well, but really, if you look at your trig functions, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent's opposite over adjacent. Which then the idea was brought up, well, then really your x value is your adjacent every time. Yeah, that makes sense. Your y value is your opposite. Yeah, that makes sense. And then your r value is r. It's your hypotenuse. So really, couldn't I just, on every one of these, when I'm given the point, say adjacent, opposite, and then I'm finding my hypotenuse and do my trig functions and not even draw a picture? I'm like, let's try it. And we did, and it worked. So here's what I mean by that. I'll actually do a homework problem doing this. So you can be like, oh, I kind of see what you're talking about. So if we take that idea, let me see if I can get this on the screen at the same time so we got something to work with here. Okay, cool. So let's find one that we actually had to do from the homework. So let's say, for instance, 24. It's the first one. So if some of you haven't started, you now will have one problem done. Okay, so if we're looking at number 24, the point I'm given is -6, -8. Now, using our newfound idea,
Wow, seriously.
-6 is our adjacent, -8's our opposite. Just like in the alphabet, A comes before O. So it's even easier to remember. When I'm trying to find my R, I square each of my values. Remember the parentheses, because if you don't, you're going to get funky, mixed up answers. So let's see. My R, 36, and 64 is 100. The square root of 100 is 10. Okay? So that's my hypotenuse. Adjacent, opposite, hypotenuse. I got this. All right, let's check this out. So now, I don't even have to play this funny game with YR, XR, YX, because I know what all the pieces are. Sine is opposite over hypotenuse. And of course, I'll reduce the fraction. Cosine is adjacent over hypotenuse. And I reduce the fraction. Tangent is opposite over adjacent. And I reduce the fraction. And again, that time, negative divided by negative is making that positive. If I got those, I got the other three, because again, it's just the reciprocal. And I absolutely found that to be brilliant. And I've got my trig functions. Now, if you still like drawing the picture because you visually want to see opposite and adjacent and a hypotenuse, that's fine. But I know a lot of you always are looking for a way to simplify some things up and maybe save a little bit of time. That works, and it works every time. So if you were looking for that, good deal. That's definitely an option that you would have here. Okay. So here's what we are going to take a peek at now, kind of in building on that, because this is what basically the part we got to yesterday, was dealing with some of this. Now, if I remember correctly, but I am going to kind of do a rewind on this and kind of let us talk back through it again. When we got over to the back side of this, because if I'm remembering right, we got to the back side in here, right? We got to here? Okay. I just want to go back over a couple of things here quick, just as a review. So if you've got your pictures and stuff, just kind of sit back for a second, kind of watch this again, just to make sure that we've got this. Because I know sometimes at the end of periods, we get rushing along here real quick sometimes. I know that never happens, but it does. And we tend to, lose sight of things. So when we talked here about sketching the angle, and again, I'm going to be a bad person since we are in review right now. I'm going to literally sketch. So 135 degrees, again, start at 0, go to 90. I need another 45. So I get my 45 drawn in here. And I know this is 135 to here. Now just remember again, when you're looking for the reference angle, how far is it to the x-axis? Every time, wherever I stop, wherever my terminal side is, my question is, how far is it to finish? So I got two ways of doing that. If I'm looking at it, and I'm like, well, this is 90, and this is 45. Well, I got 45 more to go. So, that's my reference angle. But I also can look at it as, again, it's in quadrant 2, so I can just do 180 minus 135, and I can get the 45 that way. So either by formula or by what I visually see. The thing I always got to keep stressing to people is you're not necessarily going to keep going around. Sometimes you're going to go back. So when we're doing 200, so you're like, okay, 90, 180, and I've got my little old angle here, because I know to get my 200, it comes all the way around. But I know this piece in here is 180, and this is 20, okay? That 20 is my reference angle. It's how far to get back, not to get to the next axis. And if I wasn't sure, I'm in quadrant 3, so I just subtract 180 from it. Same thing. Multiple options, multiple tools you can use. Doesn't matter which one you use. And then just to remind you one more time, before we hit up the next part, because this is going to kind of roll right into it, I'm going to get this back into degrees so it's a little easier to play with. Once I've got that out of there, I'm just going to multiply across. Oh, thank you. And I start to work my way around, and I go, okay. I know that all the way around here is 300, but I know 270 of it gets taken up to this point, which means I've got 30 left here, but, and this is the one that people start to get caught on, because they go, oh, it's 30 from here to here, that's the answer. That's to the y-axis. How far is it to finish off and get back up to x? Right. This is 60. Or, since I'm in quadrant 4, I can do 360 minus 300 and get back where I'm looking for. Okay? Always, how far am I away from the x-axis is the question that has to keep being asked when you're doing reference angles. Okay, especially if you're sketching. All right. Any issues with that in the review before we do our one last thing with this? You're like, eh. I know, that's so quiet all of a sudden. Okay. So last thing. All right, evaluating trig functions. Now, I am going to be as honest can be as we start here with a couple of things. Here's one way to help you remember what signs your answers are going to have as you're working through these, okay? There's always little tricks to everything. In quadrant 1, all of your trig functions have a positive sign. They'll have a positive answer. But as you start to move around the quadrants, it changes. So for instance, in quadrant 2, only sign on its inverse are positive. So I kind of like to remember that with an S here. In the third quadrant, only tangent and cotangent are. And when I get to quadrant 4, it's only cosine. So here's the way I like to remember this, to remember which quadrant's positive and negative. All students take calculus. Okay, I'm the math teacher, so that's the kind of saying that I'm going to come up with. But you can come up with your own on that if you wanted to. That's how I know my signs. Now, to figure out the other part, because some of you are going to figure out after a while with this, hey, couldn't I just plug this in the calculator and get the answer? And the answer is yeah. Which is why when we're doing it on the homework, and also when we're doing it on the quiz, I'm going to put on there, show me the special right triangle you're using to figure this out with, and give me the answer without decimals. So, it's a nice backup, but it's not something we're just going to start doing. So here's, and they just said, oh, special right triangles. I remember these, because we did these before. When we're talking about special rights, and I'll draw one on each side here, we're talking about 30, 60, 90, and 45, 45, 90. Those will get you the answer to every single one of these. So just as a reminder, if I'm doing a 30, 60, 90, my base is going to be, and they're like, ooh, it's not just x's this time. My side opposite 30 is going to be 1 instead of just x. My long side, my side opposite the 60, is going to be the square root of 3. Because before we called it x square root of 3. Now we're just going to call it the square root of 3. And my hypotenuse is going to be 2 instead of 2x. Because these values aren't going to change at all. It's not like I'm going to plug a value in and make all the changes that we did when we were doing special rights before. Those are the three numbers that are going to get used every time. And then on 45, 45, 90, the numbers that we're going to use every time are going to be 1 for each of my legs and the square root of 2 for my hypotenuse. So when we're doing these problems below, we are drawing a picture every time. I even draw pictures when I'm doing these instead of just doing them off the top of my head. So here's how this is going to work. When we say find the exact value for each trig function, you're like, seriously, you're going to make us do all 6 for these? Yes. Okay. So we're going to skip around when we're doing these a little bit so we can take a little more room to draw pictures and kind of see how this is working. Oh, actually, we're just going to do it for one. It says the exact trig function, not all of them, so ignore me. Okay. So you're like, how is this going to work? All right, I'm going to draw a picture. Now, before I ever start, sine 150 degrees, what quadrant is that in? 2. Okay, so we're going to be in quadrant 2. Is sine positive or negative in quadrant 2? Positive. So I know my answer is going to be positive. If I get something else, I know something went haywire. So when I go to do this, I'm going to let you guys get away with not being perfect on your sketches. So if I was to go ahead and draw this, all right, so I get to 90. How much more do I need when I get into my next quadrant here? 60, because I need to get up to 150. So we're going to sketch here. I'm going to trust your judgment on this. So you're like, okay, so I drew this angle, now what? Here's how this is going to work. Bring it on down to finish your triangle, which will form a right angle. So we're going to be doing some right triangle trig. Now let's think about this for a second. All right, so coming from here to here was 150 degrees. What's my reference angle? What measurements? That's going to be 30, because if it's 150 to here and I'm trying to finish it off, this is going to be 30. Let me jumbo size a little more here. And so this guy is going to be 60. So once I know that, and I know what my form's going to be, sneak it back into the screen here a little bit. Okay, my side opposite my 30 is 1. My long leg, my leg opposite the 60, is the square root of 3. And then this is going to be 2. So now what I'm doing is I'm actually going to find the sine of my reference angle. Because you're like, well, if I'm supposed to find sine of 150, I don't have a 150. Okay? Since my reference angle is 30 degrees, what I did to finish this off, my job now is to find the sine of 30 degrees, because I would get the same answer, and I'll literally show that to you here in a minute. So the sine of 30, here's my 30-degree angle. I'm not going to punch it in the calculator because I don't need to. Which sides do I use for sine? Try that again. Yeah, opposite over hypotenuse. So let's check and see. Now, again, it doesn't hurt to check an answer with the calculator. I don't care. Okay, so let's do sine of 30, 1/2. Well, so that sine of 150, 1/2. So what I'm having you do, because when you get into real big boy or big girl trig, you're going to be having all of these reference angles and this unit circle and all these things to know. I'm starting to prep you for that sum now instead of just going to the calculator for everything. Because what you'll find is some of these, when you get into the radicals, you're going to look at the decimals. You're not going to know what radical that is off the top of your head. So in figuring this part out, and you'll get quicker at it too. So calculator's an okay backup plan. But like if this is an assignment and I ask you for the sine of 150 and all I get is 0.5, I'm just going to be he and hand it back to you. Okay? So, let's play along here some more. Let's go for number 12. We'll spread out a little bit here. So whenever we're doing these, we'll get our picture drawn in. All right, let's see. Yes. What are you going to do otherwise? Well, I'm not asking for perfection. We're just going to get close. Like here, 135. If I get to 90, how many more am I going to need? 45, which is halfway in. So as long as my line's somewhere close to halfway in, that's okay. Yeah. Because then when I drop this down to make my right angle, if I know that it's 135 all the way around to here, and I already have 90 of it, I know I've got another piece in here that's 45, so I need my reference angle, which is 45 degrees, which also makes my other angle 45 degrees. And then I just go into, sneak that back onto the screen here, my special right. 1, 1, square root of 2. And again, it's my reference angle that I'm looking for here. Now here's my question though, where I have to be a little bit more careful. If I just go ahead, and you're like, ooh, cotangent. Cotangent, let's see. If you have to, think of it this way. What would tangent, okay. So tangent is opposite over adjacent. So cotangent is adjacent over opposite. Well, is that really going to matter? Let's see. Here's my angle I'm using. Adjacent over opposite. So you're like, all right, so the cotangent of 135 is 1 over 1 or 1. Now, wait a minute. Now let's think about this for a second. You're like, how do I check this in the calculator? I don't have a cotangent button. Here's how you can do this. If you're ever looking for an inverse of one of these, what you could literally do is you can do 1 divided by the tangent of whatever that is in this case. Wait a minute, that says -1. What the heck?
Inverse.
Okay, well I did the inverse, that's what I did here. But why is it -1? Oh, wait a minute. Yeah, come back up to your chart for a minute. What's positive in the second quadrant?
The regular one.
Sine is. Sine or its inverse. Tangent and cotangent are positive here. That's the one thing I have to watch for when I'm doing these. Now, some of you may say, and this is the one part I was a little hesitant to talk to you about, if you know all students take calculus, you don't have to do this, but if you think about it actually, since I went left here, that technically would be -1, but I would prefer you don't go that way because too many bad things can happen. Just keep doing your regular triangles the way you have been, okay? And then you just have to play around with the signs, but that's also a nice thing about double checking with the calculator. Oh, let's find one that's going to be a little bit more interesting. Let's do 15.
Oh, nice.
Let's throw this in there too. We got to throw, got to do this. All right, let's play with degrees first.
Ooh.
Shortcut.
Nice.
Instead of having to do 180 over pi here, just replace the pi with 180
It's pi equal.
because pi equals 180. We talked about that before. So, if I want my angle, whoa, yep, it'll just be 4 times 180 and then divided by 3. Okay, so this is a 240 degree angle. Now, before I ever do anything else, let me get my sketch here. 240, 90, 180. Okay, to finish it off, here is going to get me to 240. We're always making our triangle with the x-axis. Yes. So let's see. 180 to get to here. So that's 60. And here's my 30.
30.
Now before I do anything else, okay, we're in quadrant 3. Is cosine positive in quadrant 3?
Yeah, no.
No. Okay? So I'll make myself a little note here. This is going to be negative. So if I get my answer and I'm bopping along here, I got to remember it's going to be negative. All right, so 30. We've got 1 square root of 3, and my hypotenuse is 2. And if you ever are starting to get these two confused, just keep telling yourself, 30 is the smallest. 1 is smaller than the square root of 3. Square root of 3 is like 1.41 something, something, something. So when I go to do this, I'm always using that reference, whichever one's up near the x-axis. So, cosine
Jason.
of 240, I'm always using this angle that's attached to my origin, is,
Negative.
yes, adjacent over hypotenuse, but I remember it's in this quadrant, it's going to be negative. And I can double check. Is the cosine of 240, hopefully it's going to be negative 0.5. Woo! Do we want to play with one more?
No, dude, we good.
Do we want to play with one of the homework ones?
Yes, dude.
I had a feeling. Okay, let's play with one of the homework ones. Oh, okay. Number 36 on the homework? Okay, let's take a peek. All right, move this out of the way. All right, so 13.3, number 36. Ah, we're going to bring something. Let me pull something back up for a minute. This is something we had passed over on the front yesterday that we can talk about now, because this is going to help us with 36, and then we'll do 36. on the front of your notes, there's this thing on the bottom called quadrantal angles.
Yes.
And why these occur is sometimes what happens if I can't make a triangle because I end on one of the axes
Where's this at?
on the front of the 13-3 note sheet. So what exactly do you do when this happens? Well, here's what we're going to do. Notice they give me my x and y values right here. So my x value is going to be r. Now I'll explain how this is going to work in a second. My y value is going to be 0. And if I did the Pythagorean theorem here, now this is going to be weird, so just stay with me on this.
Oh, Lord.
R squared would be the square root of r squared plus 0 squared.
No headache.
So r is still going to equal r. You're like, okay, and how did that just help me exactly? Because now, when you look at number 36, and it's going to work the same way. I'll put all of them up in a minute so you can see them. But this is the only one I'm going to be concerned with right now. So if we're doing number 36 and it says theta equals 0, evaluate the 6 trig functions.
That's beta.
Theta, yes.
Theta.
So I need to do sine, cosine, and tangent, and then their inverses. So I just found out, so I've got r0, and then my hypotenuse is r. Now, if we go with what we just talked about, this is my adjacent, this is my opposite. So if I start rolling these now, I'm like sine, okay. Opposite over hypotenuse. 0 over r is 0. Cosine is adjacent over hypotenuse. Anything divided by itself is 1. And tangent is opposite over adjacent. 0 divided by anything is 0. Be careful when you do the inverse. Flip this.
0.
What happens when you divide by 0?
0.
Undefined.
Undefined. Wait, how come?
Take that. Well, r divided by r is still 1.
Oh, yeah, because the hypotenuse is 0.
And here, flip that over. It's division by 0 again.
Wait.
So that's how I would crank out 36. And I'm really glad you mentioned that, because I almost forgot about it.
I'm listening.
And we just want, the quadrantals are very rare that they occur, but that's something I want to have. If I put it on a quiz, I'll have the key like this up. But let me just put one thing here quick in a minute, once I make sure everybody's got that jotted down, because that way we've got this set. On the rest of these, and you'll see how the pattern works here, on the rest of my quadrantals, again, I've got my points for x and y. R is always going to be itself. That's never going to change. So if you take the coordinate point they give you for each one, you basically have your adjacent, your opposite, and your hypotenuse for each. And you already hopefully jotted down the entire assignment from yesterday.
Yep.
Like, yeah.
Did them all.
Did them all.
Wait, so those are due tomorrow?
So day 1, okay, here's what we had started yesterday. You now can do them all. So here's how this is going to work. Let me make sure I'm looking at this.
Monday's homework.
Yes.
Tomorrow.
Okay, day 1 for this to be due is tomorrow. That's full credit. Friday, which will be day 2 for this, is still full credit. So if this is ready to go by Friday, you're good. And tomorrow we'll be doing a worksheet to kind of play with it too a little bit. So practice, practice, practice some more.